So any event in your application, it being a direct user interaction or something else, should run a Cerebral signal. By doing so, you get access to the features of Cerebral and the debugger gets insight into what is going on. The purpose of a signal is to change the state of your application and run side effects, plain and simple. A signal is a sequence of actions, which each of these blocks represent. An action is just a function where Cerebral inject access to state and side effects. By default, Cerebral exposes the ability to change state. Other side effects you have to define and inject yourself. This is done with providers, which you will later learn more about. An action that changes the state of your application would look something like this. When Cerebral runs an action, it injects something we call the context. The context holds the API to do state changes and run side effects. In this example, we use the state API to set a new state. When developing your app, you typically use the structuring to grab the APIs you need access to, like state in this example. If you add the HTTP provider, you would access it the same way as state. Since the HTTP provider API returns promises, we actually return that promise from the action. Returning a promise from an action gives an indication to Cerebral that this action is asynchronous. That means Cerebral will wait until the promise resolves before it runs the next action in the sequence. A sequence might look something like this. We change the loading state of the application, then we grab some data, set it, and then we change the loading state again. Creating one function for every little state change and side effect would be tedious. That is why Cerebral encourages function factories. Basically, it is a function you pass some options and it returns the function Cerebral will actually run. Nothing Cerebral specific about that, it is just how we write functional code. So instead of having two functions for changing the loading state, we could do this. Now we have one function where we pass in the value we want to set the loading state to. This cleans up a bit, but you would still have to create the function factory. We can take it a step further. Cerebral ships with included function factories for changing state, and other packages also have their own function factories. We call them operators. They help you define most of the logic in your app. In this illustration, we have not created any new functions. We are just using operators to describe the logic we want to run. When you trigger signals in your application, they're picked up and visualized by the debugger. Signals triggered, sequences run, state changes made, side effects run, and more. You have full control of everything that is happening inside your application. Read on to learn more about signal payloads, parallel execution, and diverging execution down paths.